Hello everyone, I'm your chemistry mentor Rupali Goel, and today we are going to discuss about Rutherford's model of atom. So before going into the model, we must know that who is Rutherford and why he wants to work on this topic, right? So let's discuss about that. So Bacha, Rutherford is a student of J.J. Thomson. Ma'am, who is J.J. Thomson? J.J. Thomson is the first scientist who tells us about the structure of atom. He's the one who visualized the atom first time. How he visualized it? See, he gave us an example of watermelon. See, in a watermelon, if you can see, there is a red portion and the black seeds are embedded in this red portion, right? And J.J. Thomson sir tells us that just like a watermelon, in an atom, there is a red portion. No, there is not a red portion like watermelon, but there is a sapphire of positive charge, just like the red portion in the watermelon. And the electrons, the negatively charged electrons, are embedded in this sphere, just like the black seeds are embedded in the red portion of your watermelon. Right now, Rutherford is the one who modified the structure of your atom and bring this crisp structure towards us or around us. So let's discuss about the model of atom and let's see what are the experiments involved in this Rutherford's model. Right. So the experiment included in the Rutherford's model is alpha ray scattering experiment. What is the experiment? See, first of all, Rutherford take a very thin gold foil. He take a very thin gold foil of around 1,000 atoms. He considered that this gold foil, this yellow plane, that is your gold foil, is containing only 1,000 atoms. Right, so that means this is very, very thin, right? And the alpha rays that are highly positively charged rays, they are having two positive charge on them, but brought to, or you can say were made to bombard on this gold foil, right? And this folded circular path is a screen, that is a fluorescent screen made up of zinc sulfide, and it is placed behind your gold foil, right? So in this whole experiment, let us discuss about what are the observations and how we comes to the conclusion of nucleus, right? So see, this is basically your experiment. We have enlarged the gold foil, and now we will discuss that how alpha rays interacted with your gold foil and what are the observations. Your first observation is these alpha rays, like if we are having 1,000 alpha rays, out of 1,000 alpha rays, almost 800 rays went straight. They do not, or they do not deflect from their path. They go just straight. So first observation is most of the rays pass through your foil without undergoing any deflection. This concludes that the most of the space inside the atom is empty. See, if your alpha rays are not interacting with any kind of material, right, that means they are going straight. They are going straight because they're not interacting with any of the material, right? Hence, if you can say 800 rays are going straight, that means most of the space inside your atom is empty, right? The second observation is some of your alpha rays got deflected from their path. You can see it is going like this and deflect, right? This ray is going this and deflect, right? That means some rays are also deflecting from their path, right? The second observation is few of the rays undergoes deflection through small angles, right? So What is the conclusion here? Your Rutherford conclude that being a positively charged, alpha particles must deflected because they must come in contact with a positive body. Right? See, alpha particles are having positive charge, right? If see, one body is positively charged here and one body is positively charged here, and if they come in contact, what happen is they repel each other, right? They repel each other. Now if I say that this is a positively charged body, and this is your, let's say, alpha ray, and it's going this, and what happen is it's deflected from its path, right? It happens, no, because both are having positive charge. So this same condition was happening in your Rutherford's experiment, right? So from there, they conclude that your alpha particles are deflecting or were deflecting because there is some positively charged body present in your atom, right? Your third observation is if there are 1,000 particles, out of 1,000 particles, let's say only one particle is retracing its path, just like this. See, this alpha ray is going this, and it retrace its path, right? It is deflecting almost at an angle of 180, right? So this is your third observation, that 1 in 1,000 rays got deflected by an angle of 180 after hitting the gold foil. So what is the conclusion here? Alpha particles are heavy particles, right? They are having 4-unit charge. That means they are very heavy. These could be deflected back only when they strike to a very heavier body inside the atom, right? One heavy body, if you can see, we are saying that if this is your alpha particle, and if um, while you can say when they bombard with each other, if it is retracing its path, that means if your alpha ray is heavy, this body must be heavier, right? That is why see, if this body is very heavy and this body is also heavy, when they interact with each other, it retraces its path only in one condition, when this body is heavier, right? So this concludes that in your atom, the body which is positively charged is also heavier in nature, right? So this is basically your experiment. There is also one more observation. The fourth observation is this: since the number of deflected particles are very small, if you can see, if there are 1,000 particles are interacting with your gold foil, only one particle is deflected back at 180, and very few particles are deflecting at small angles, right? That means that positively heavy charged body must be occupying very small space, right? If it is present in very small space, only in that condition only few particles are interacting with that body, right? So from these all observations, Rutherford tells us about the structure of atom, the modified structure of atom. So this is your atom in which positive charged body is present in the center, and the electrons are revolving around these a circular path, right? So this is your revolving electron, and this body is your nucleus, right? So your Rutherford also compare its model with the solar system. So how this comparison occur? See, in your solar system, there are so many orbitals, right? And the sun is placed in the center of these orbitals, and the planets are revolving around the sun in their particular orbits, right? So In atom also, the central heavy body, the positively charged body, is a nucleus, and the electrons are revolving in these orbitals around the sun. So in this way, you can see Rutherford modified the structure of atom very well and tells us about very interesting subatomic particles in a accurate way. So this is your Rutherford's model. I hope you have understood it very well. So thank you so much, students, for listening. I hope this video will help you to understand this concept very well. Thank you.